Okay.
Just look right now.
Use a new link.
Yes. You show it to
Okay.
follow it to
Does it plug in power bank? Mm-hmm.
please just show
Okay.
the
Have you copied it? Copy.
show the sorry.
Okay.
Let's try. Let's try and watch more videos.
Okay. 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 No problem.
Right option. Yeah.
All right. So everybody, please join the new link. Please let's join the new link. Let's join the new link. All right. The link is giving us some challenges due to network glitches. I'm very sorry for this. This is beyond my control. It's beyond my control. All right. So join the new link that you're going to see right now. Don't just join the link. Please make sure you share. Share the link now so that many persons can get to have it. Thank you so much. Elijah, share this link now. Share this link. Share the new link. Everybody, if you're here, please share the new link right now. Share the new link as soon as possible. All right. Thank you so much. All right. Yeah, yeah. You're not projecting, are you? Okay. Okay. All right. So if you are here, just let me know you are here. All right. The previous link is giving us issue. We have to use a new link. We have to use a new link. Okay, it's moving right now. Okay, okay. All right. So Chimamanda, is everything okay? Elijah, is everything okay now? I just want to be sure before I begin. All right. Sam Olokot, is everything okay? Are you seeing the video? Are you seeing the audio? All right. Video and audio. Are you seeing the video and the audio? Can you see the first question? And you're hearing me loud and clear. You're hearing me loud and clear. Yes. Yes. Sometimes you can change it, but don't change it yet. Okay. All right. All right. So the help you're going to do for me, go to your Facebook. If you're on Facebook handle, share the link because some persons are still on the previous link. Some persons are still on the previous link. You can share the link on Facebook. All right. Share the link on Facebook. Okay. Well, I dropped the link in the other comment section. All right, all right, all right. So we are good to go right now. We are good to go right now. And so you can see the very first question on the board, and that is the question that we are going to begin with. That's the question we're going to begin with. And the question says, the nitrogen atom has 7 protons and 7 electrons. The nitride ion will have. Thank you so much for sharing. Thank you so much. So, because it's a ground state, number of protons is equal to number of electrons. So, from there, we asked to find in this question is that you have to find the number of protons and number of electrons that will be present in the nitride ion, 5 in the periodic table. That means it has 5 valence electrons. Nitrogen in group 5 has 5 valence electrons. If either nitrogen loses 5 electrons in a chemical reaction or it gains 3 electrons. For octet structure to be achievable, and nitrogen being a non-metal that it is, it will be easier for nitrogen to gain 3 electrons. If nitrogen gains 3 electrons, its ion, called the nitride ion, would be represented as 3 minus. From there, we see that if nitrogen gains 3 electrons to be 3 minus, the number of protons still remains 7 protons. And the number of electrons, 3 electrons being gained, that will now be 10 electrons. Critically, you can see here that nitrogen has 7 protons and 10 electrons. So the nitride ion contains 7 protons and 10 electrons. But the nitrogen atom at ground state contains 7 protons and 7 electrons. So, if you look at this, you discover something. That in the option that we were given, the answer or the option that fits this is option B. Answer is B. 7 protons and 10 electrons. 7 protons and 10 electrons. 7 protons and 10 electrons. All right. Rebecca Omoren, thank you so much. Is good. I'm happy to hear that. That is good. And oh my God, I'm glad right now. So from there, I just hope you're not having a screen blackout on your area. I just hope maybe it's my network that's giving me a blackout right now. Okay, I'm back. All right. So based on the one question that was just answered right now, if you have a question, you can drop it on the comment section so that I see how I can answer you. If you look at what is happening in this class, I'm trying to see how you can follow to the best of your ability. I'm trying the best I can to make sure you're following everything we're doing right here, right now. If you have not yet shared the live stream, please make sure you share the live stream. If you have not yet subscribed to my channel, make sure you hit the subscribe button. If you have not yet liked this video, click button. Thank you so much. As we proceed, I believe your writing materials are ready. If you're just joining us, I believe that this is going to be a very interesting. Don't worry about the fact that we could not really make progress as far as we're supposed to because of network glitches. That would not hinder this. Let us continue. So if you have a question, you can drop it in the comment section so I can answer you. So far, I've not seen any question on the comment section. Does it mean that we all understand? I assume we. Question number 2. Question number 2. Question number 2 says the IOPAC name. Question number 2. Okay. The IUPAC name for CH3, CH2, CH, a branch there, CH3, and then COOH is the IUPAC name. So that compound you're seeing there name for that compound. A, methyl butanoic acid. B, butanoic acid. C, methyl hydroxyketone. D, 2-methyl butanoic. I have to make some adjustments so that we can just be in alignment with the options that we have. CH2, CH branch, CH3. Applying the rules for naming organic compounds. Making progress from there. But which longest carbon chain are we going to make use of? Is it this or is it this? We give priority to the functional group. Remember, when we are numbering to determine the longest carbon chain, the first thing we do is that we have to put into COOH, which is the alkanoic acid or carboxylic acid functional group. So put COOH, that means this is butanoic acid. Is there anything not part of the longest carbon chain? Yes. This is CH3, which is a methyl. That is a side chain or a substituent. How am I going to number this? Am I numbering in 1, 2, 3, 4? Or I'm numbering this other way 1, 2, 3, and 4? In numbering or in assigning locants or numbers, preference is given to the functional group, so that the functional group, which is the suffix, should give us the lowest possible number. If we number it from left to right, the carbon atom, which is part of the root carbon atom that forms part of the suffix, is giving us number 4. So it's always advisable, according to the rule, to number from right to left, such that this will give us the lowest possible number. So this numbering is not correct. It's not appropriate. The correct numbering is from right to left. So this is the first carbon atom, this is the second carbon atom, this is the third carbon atom, this is the fourth carbon atom. Moving forward from there, we can see that this is methyl is at the second carbon atom. So we can call this that this is 2-methyl, 2-methyl, don't put a space there, 2-methyl or methyl butanoic acid. So the correct answer is D. From the question we've just solved, you can Mimi K, I'm glad that it's starting to clear up. It will clear up more. Thank you so much for that honest review. Thank you so much. Thank you so much. So based on that, if you have a question in what we've just done, you can drop a question so that I will be sure that you understand what we're doing before I move to the next question. All right. Okay, Justice, Sir Justice, we're having a network glitch, so just be on with us for a while. Join the new link. We are rectifying the issue. All right, so join the link there right now. Let's begin, or let's continue. Question number 3. Question number 3. Question number 3, which is right, reaction of alkanoic acids with alkanoates are formed by the reaction of alkanoic acids with A, halide, B, alkanol, C, ester, and D, okay, C, ester, okay, C, ether, all right? And there's no option D there. I think option D there should be ester. Option D there should be ester, all right? Sorry, that was not included in the options. Alkanoates are formed by the reaction of alkanoic acids with A, halide, B, alkanol, C, ether. We should have an option there which should be ester. you should know that there is a difference between ether and ester. There's a difference between ether and ester. So ether has the general formula ROR, while ester has the formula RCOOR. Where this R could be the same alkyl group or different alkyl groups. And R in ester, I have a COO there. This differentiates ether homologous series from ester homologous series. Of course, alkanol is ROH, all right? It's ROH. I just said, let me clarify that. Now, for an alkanoate to be formed, alkanoic acids must react with, the correct answer is alkanols. For alkanoate to be formed, alkanoic acids must react with alkanols. So the correct answer is B. It cannot be ester because alkanoate is an ester itself. Alkanoate to be formed, it does not have to react with itself. So the correct answer is alkanol. And that process in which that reaction takes place is called esterification. 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 So I don't know if we were able to project that one on the board. All right, because I didn't see it here. Okay. Okay. All right. All right. So with the next, can we have the next on the? All right. So let's us move to question number. The question number 3, the correct answer is alkanols. Question number 4 says calculate the pH of 0.001 mole HCl. 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 0.001 mole HCl. I am to find the pH, all right? I should have looked for options and structure for you, but this is a practical Jamb question. Calculate the pH of 0.001 mole HCl. What is pH? pH basically can be called the potential of hydrogen. And also you can say pH is the negative logarithm of the hydrogen ion concentration present in a solution. The negative logarithm in this question, it is that definition which you're going to use to do what? To find the pH. Negative logarithm of the hydrogen ion concentration is that what you're going to use. Now, it's important you note that from there, you need to find the hydrogen ion concentration. How will I find the hydrogen ion concentration? To find the hydrogen ion concentration, the first thing we need to do is that we need to represent HCl in its ionization equation. HCl ionizes to give 1 mole of hydrogen and 1 mole of chlorine. In this, we will say as it is balanced, this is 1 mole of hydrogen ions. So this 0.01 mole M. This M is telling you that this is the concentration. This is the concentration in mole per dm3. Concentration in mole per dm3. So you now say that the hydrogen ion concentration, since I have one here, it is 1 times 0.001 mole dm3. Whenever you see mole, capital letter M, know that that means that that value is in mole per dm cube. So that gives me 0.001. Change it to standard form, that is 1.0 times 10 raised to power minus 3. That's my hydrogen ion concentration. This is the same thing as 10 raised to power minus 3, because 1 times anything is still that same value. So to find my pH, my pH is simply going to be minus log hydrogen ion concentration 10 raised to power minus 3. Now, in doing that, pH will be 10 raised to power minus 3. Remember that in your rule of logarithm, one of the rules of logarithm is in mathematics, this will come down here. That will come down there. So pH would be equals to minus 3 log 10. One thing you fail to understand is that the pH is minus into minus 3 log 10. I did not put any base in this logarithm. When I don't have any base in that logarithm, it means that that logarithm is in base 10. So another thing where I can write that is plus 3 log 10 in base 10. And log 10 in base 10 goes, and that is 1. So this is 3 times 1. So the pH is given as 3. The pH is given as 3. Some questions can say, find the pOH. Find the pOH. Now, if you are to find the pOH, if you were asked to find the pOH, what will you do? pH plus pOH is equals to 14. I know pH has 3. I'm looking for pOH equals to 14. Make pOH a subset of formula, so that will be 14 minus 3. So pOH is given as 11. I am just solving that in case you were asked to find the pOH. Just in case you were asked to find the pOH. All right. So moving from there, we have treated question number 4. Someone is just telling me now that I should go answer question number 3 again. Question number 3 said, alkanoates are formed by the reaction of alkanoic acids with A, halide, B, alkanol, C, ether, D, ester. The correct answer is alkanol, because alkanoates are esters, and esters or alkanoates are formed when alkanoic acids react with alkanols. So in question number 3, the correct answer is alkanol. Let's move to question number 4. Question number 4 is what we just finished doing right now. Now we're to find the pH of this. Okay, lovely astronomical model. I love that name, man. Lovely astronomical model. You said you have a question concerning pH. Please, can you drop your question ASAP? Can you drop your question? Can you drop your question as soon as possible concerning pH? All right. I'm attending to your questions. What question do you have concerning pH? I'm waiting for your question. Mimi K, I'm seeing your question right now. He said, why did I add log to it? Why did I add log to it? This is the definition of pH, aka potential of hydrogen. pH is a measure of the potential of hydrogen in solution. It is also a measure of the acidity or the alkalinity of a particular solution. I added logarithm to it because that is a mathematical definition of pH. That pH is the negative logarithm of the hydrogen ion concentration. This is the formula. So I represent the acid, the ionic representation of that acid, and this is what I have. And 0.001 means that that is the value in mole per dm cube. I put that in standard form, and this is what I have. I put H plus back inside that formula, and this is what I have. From logarithms, this comes down, and then log 10 in base 10 That base, because there's nothing there, the base is 10. My answer is 3, pH is 3. Jamb may ask you, find the pOH. pOH means the potential of hydrogen. That you use the formula that says that pH plus pOH equals to 14. pH is 3, pH is not known. So to find pH, take 3 to the other side. 14 minus 3 gives you 11. Sebastian Warrior, you're welcome. You're welcome here. Sebastian Warrior, you're welcome. You're welcome. All right. So number 3 question, TCAC. I have gone through number 3 question again. Chimamanda, you have a question in pH. I told you to drop your question. I don't know why you have not dropped the question until now. Okay, Lovely Astronomical is asking me, how can you use pH to find the H? How can you use pH to find the H? I love that question. How can you use pH to find the H? All right. Mimi K, you are welcome. Mimi K, you're welcome. So I want to answer the question by Lovely Astronomical. How you can use pH to find the H. So Lovely Astronomical, make sure you're paying attention. Remember that I use the H, I found the H, and I use the H to get the pH. Now, let us see how we can use the pH to find the H. Let's go. How to use pH to find H. How to use pH to find H plus. How to use pH to find H plus. So we have found H plus, assuming that H plus, that pH rather is 3. How do I find H plus? I will still use the formula that pH is equals to minus log H plus. pH is what? 3 equals to minus log H plus. The first thing I will do, I divide both. You know that there's an invisible one here, coefficient of log H plus. So I'll divide both sides by minus 1. I'll divide both sides by minus 1. When I do that, 3 divided by minus 1, I'll have that minus 3 is equals to log H plus. I want to make H plus the sort of formula. To make H plus the sort of formula, there are 2 ways I can go about this. I will take the logarithm to base 10 of both sides. Or I will just take the antilog. I repeat myself. I will take the power of 10 to both sides. Or I will take the antilog. This is the same thing as saying, in mathematics, listen, in mathematics, what you're seeing here is something as log H plus equals to minus 3. In a rule of mathematics, if log P in base Q is equals to X, Q can cross and it become what? P is equals to Q raised to power X, and vice versa. I want to find H plus. Log P in base Q is equals to X. I can make P to stand alone by Q crossing to the other side. If Q crosses to the other side, what I now have is that H plus is equals to, I hope you know that the base is 10. There's an invisible base 10 here. So when it crosses, this will be H plus is equals to what? 10 raised to power minus 3. Are you seeing what is happening right there? This is applying the rule of what? Indices. Applying the rule of indices. So that crosses. So you can see that my H plus is equal to 10 raised to power 3 mole per dm cube. Another student can decide to do this. Log H plus equals to minus 3. Can decide to take the antilog of both sides. Antilog of log h plus equals to antilog of minus 3. Antilog of this means 10 raised to power log h plus. Antilog of minus 3 means 10 raised to power minus 3. Because this antilog of minus 3 is to base 10. Base 10. So 10 raised to power minus 3. So this antilog of log h plus is to base 10. Is to base 10. That's why I'm saying 10 raised to power that. 10 raised to power this. From rule of logarithm, since this logarithm is in base 10 also, what will cancel is that h will come down. That is 10 raised to power 3 mole per dm cube. So that is how we can use the pH. That's how we can use the pH to find the h plus 10 raised to power minus 3. All right, so let us proceed to the next question. Let's proceed to question number 5. Question number 5. Calculate the. I just hope I was able to answer that question of calculate the pH of 0.001 mole H2SO4. H2SO4. 0.001 mole H2H. You can see there that for H2SO4, the first thing I have to do, in its ionic representation, that will give me 2 moles of H plus SO4 minus. So that means that the hydrogen ion concentration will be 2 times what I am being given. So that's 2 times 0.001 mole per dm cube to 0.001 mole per dm cube because of these two. So from there, I can now say 2 times that will give me 0.002 mole per dm cube. And in standard form, is most preferably written as 2.0 times 10 raised to power minus 3 mole per dm cube. Yes, mole per dm cube. Now, from there, we move, and then what we have is that. Now let us find the pH. The pH is minus log hydrogen ion concentration. So pH will be minus log, the hydrogen ion concentration is 2.0. And 2.0 is the same thing as 2. So this is times 10 raised to power minus 3. So this will be the same thing as, because this logarithm affect 2 and also affect 10 raised to power minus 3. So pH will be minus into log 2 times log 10 raised to power minus 3. Yes. Now, this is minus into the value of log 2 is 0.3031. Now, listen. Because we have changed the value of this logarithm, the rules of logarithm say that you are multiplying logarithms of the same base, it will change to plus. So this is what? This is minus 3 log 10 in base 10. Are you following what's happening right there? This is in base 10. This crosses over and becomes minus 3. So pH with minus into 0.3031 plus minus is minus. Of course, log 10 in base 10 is what? 1. Plus minus is minus 3. So pH is equals to minus into 0.3031 minus 3 will give us what? will give us what? It will give us a negative answer. It will give us a negative answer. And that answer, if you check your calculator, so if you check your calculator, that should give you 1999. So this is 96, and this is 96. Yes, 96. Yes. So the answer will be minus 2.6969. And someone can confirm this answer for log 2. The value of log 2 should be 0.3031. Value of log 2. So if I made a mistake in that value, that is not a big deal. Get the correct value for log 2. Log 2. So my pH will be minus into minus 2 points, and minus into minus 2.696. My pH will now be equals to plus 2.696. Yes, 69. All right. Please, someone should confirm the value of that logarithm for me before we proceed. This, so that we're sure. If there's a mistake here, I'm having a mixed feeling here. Just check it out. If there's a mistake here, we know that we just have to do just a little correction before we proceed. All right. 3010. All right. Thank you so much. Thank you so much. Thank you so much. Thank you so much. Who was that? Mimi K. Thank you so much. Mimi K. Thank you so much. 3010. Thank you so much. So you see why I was saying that we should be with our calculators, we should be with our materials. So 3010. So that's the correct answer. That's the correct thing. 3010. And so if you do that subtraction, 3010, so that's 0, and that is 9, and that is 9, and that is 3010. Yeah. So 699. Yes. So that would be an answer. 699. That would be an answer. Yes. So we are good to go. We are good to go. That's our pH. That's our pH. So approximately, yeah, that's true. Thank you, Mimi. Mimi, thank you so much, Mimi. You're following us. You're following us. So that would be the pH for that question. Hmm. All right. I just saw a question from Team Amanda. If you are following us, if you check the comment section, you see a question from Team Amanda, and she gave a very interesting question. Team Amanda said, what is the concentration of hydrogen ions in moles per dm cube of a solution of pH? So from the question that Team Amanda gave to us, pH is 4.398. All right, and you are to find the hydrogen ion concentration. So pH is minus log H plus, minus log H plus. We have to find the value of H plus, and we are given pH as what? 4.398. Now, if you're watching this right now, check your comment section. Chimamanda just dropped a question for us that we should do it together. And that's the question I'm trying to solve now. The question given by Chimamanda from the comment section. In the question that Chimamanda gave to us, the concentration of hydrogen ions is 4.398. And we are to find, okay, the pH, no, it's the pH. The pH is 4.398. And we have to find the hydrogen ion concentration, which is H plus. And we know that the formula is pH equals to minus log H plus. So what do? We now say that bring in your pH 4.398, and then this is equals to minus log H plus. Whether I put the bracket or not is still the same thing. So The first thing I'm going to do, I'm going to divide both sides by minus 1. Yes, so that's minus 4.398 equals to log h plus. This is the same thing as saying that log h plus is equals to minus 4.398. This is the same thing as saying that log h plus in base 10 equals to minus 4.398. What does this mean? Take the logarithm of both sides. If you take the anti-logarithm of both sides. If you take the anti-logarithm of this side, log 10 will go. It's only h plus that will remain. If you take the anti-logarithm of this side to base 10, anti-logarithm of this means 10 raised to power minus 4.38. So I am taking the anti-logarithm. I am taking the anti-logarithm of this, taking the anti-logarithm of what I have in this side, all right? And if I take that anti-logarithm, what I'm going to have, anti-logarithm of this, I will have h plus remaining. Or I apply this my rule, that log p in base q is equals to x, that if log p in base q is equals to x, then p is equals to q raised to power x. What happened? Q came and carried x as a power. So what we will do now is that 10 will come and carry this as a power. Logarithm disappears, h plus remains. That means that h plus is equals to 10 raised to power minus 4.38. 10 raised to power minus 4.38. So from there, this will be the value of the hydrogen ion concentration. And to evaluate this, you can make use of your calculator and punch 10 raised to power minus 4.38. So can someone check this in his calculator for me? 10 raised to power minus 4.38. What will be the value? What will be the answer for 10 raised to power minus 4.38? Jamb may not ask you this kind of question that will demand you to use calculator to punch this. May not, because the functions in the calculator is restricted or limited. But YA can request this from you. Evaluate 10 raised to power minus 4.38. What will be the answer? Ten raised to power minus 4.38. So can someone check that up? 10 raised to power minus 4.38. I'm waiting for you. All right, someone should do that for us by now. So the hydrogen ion concentration will be 4.17 times 10 raised to power minus 5 mole per dm cube. That means 0.000417 in decimal form. Sorry, it was 398. My bad. So check it out. 398. So it will be something close. All right, the error would not be much. 398. So 398, not 38. So check it out. 398. All right. So let's proceed to the next question. Let's proceed to the next question. If you use 398, you will have 4.00 times 10 raised to power minus 4.00. That means 0.000400 mole dm cube. So Chimamanda, your question have been answered. So I don't know if any other person has a question on what we have done so far. Yeah, that's correct. 3.99, that's still very close. 4.1, that's close. So let us move. The next question. So question number we move to question number 6. Question number 6. Question number 6 is a simple one, and it says, what type of reaction? What CH2 plus H2 to give CH3, CH3. CH3, CH3. All right. Chimamanda, that's good. I'm glad you're following. All right. So, question number 6. What type of reaction? What type of reaction is this? What type of reaction is given above? A, is it substitution? B, is it addition? And C, elimination, oxidation? So, what type of reaction is given above? What kind of reaction is given above? If you look at this reaction, it is obvious that we have seen a double bond here. The compound here is obviously a thing. So if I'm to draw that structure well, this is the structure you're seeing there. And I am adding H2. What kind of reaction is that? The hydrogen gas will break this bond. When the hydrogen gas breaks this bond, what you have is that this bond, this is what you now have. This bond has been broken. When this bond is broken, the double bond is no longer there. So this carbon atom is free to accommodate another atom. And because that was done by this hydrogen atom, one of the hydrogen atoms will fix in that place. And what we now have is CH3, CH3. This is the condensed form of the molecular formula. Of course, we know that this is ethane. So, ethane undergoes addition reaction with hydrogen to give ethane. Some questions can come, what will be the product? But that was not the question. But the kind of reaction that's going on right there is addition reaction. In addition reaction is breaking of bonds. Unsaturated compounds undergo addition reactions. And when I'm talking about unsaturated compounds, I'm talking about alkenes. I'm also talking about alkynes. Chimamanda, you're welcome. You're welcome. You're welcome. All right. Let us move to the next question. Because of our time and the target we want to reach, this question may likely be our last question in chemistry. Yes. And the question is very simple. So maybe I should give you the options first. C3H6, C2H2, C4H10, D C2H4. Now, I need to say this before we begin. Just in case you wanted to jot some things down and it's as if maybe I'm too fast and then you couldn't get the time to jot some things down, and maybe I think about, no need to worry. Even after the live session is over, you can always go back to watch the video. The reason for the live session is so that I can be taking live questions and entertaining it as the class progresses. If you have not liked this video, you share this. Thank you. so much. The next question, which is going to be the last question we're going to do in chemistry. In chemistry, as we proceed. Before I read the question, these are the options. Before I read the question before you, I want to see it in the comment section. After this, we're supposed to move to physics. So I want you to decide. Should we move to physics before 11 o'clock or 11:30? Should we move to chemistry, physics first before? And if we move to mathematics after now, that means we may likely not do chemistry tonight because of the time, the constraint of time that we have. All right. And if we move to mathematics first, it means we may likely not do physics. If we move to physics first, it means we may likely not do mathematics. Or we are going to cut short the time and just make sure that we touch something in physics and touch something in mathematics. So let me know your view in the comment section. Let's move to the last question in chemistry before we move to the next subject. Ubon Stanislus, I want to hear you in the comment section. Should we do physics and leave math? Or should we do math and leave physics after now? Or should we do a little in physics and a little? The comment is for you. Put something there. All right. So the next question, which the last question in chemistry says, which of the following is a saturated hydrocarbon? 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 Oh my God, I love what I'm seeing, man. Ezekiel Akon has already given the answer that the saturated hydrocarbon in that question is option is an alkyne. B is not saturated. C2H2 is an alkyne, I think. Yes, this is the structure. Ubong, I have to call you out too. Okay, Ubong asks, okay. This is an alkyne. So C, B cannot be the correct answer. Look at A, option A. Option A says C3H6. C3H6 are 1, 2, 3, H6, 1, 6. Okay, that means there's a double bond there. Alkene. I think this is pro6. So that cannot be because of the double bond. Such double bond or triple bond. So you take note. Look at option for C2 and oil saturated hydrocarbon. It's an unsaturated hydrocarbon. So from there, we proceed, and D cannot be the answer. If D cannot be the answer, that means that the only answer that I have left here is C4H10. C4H10. That is the only option that has single bonds throughout. And this is butane. This is butane. Butane, which is saturated, single bond predominantly as a functional group, that is the answer. That is the option that is saturated. So the correct answer to that option is option C. I was so impressed you got the answer before I. All right. Lovely astronomical. If you can't see something on the screen, I think that is from your network because Rebecca Omoren is seeing. Oh, even Otobo Omo cannot see anything what we are doing, so that I'll be sure. Let's confirm, please. But Rebecca Omoren is seeing something on the screen. She's seeing something on the. Okay, let's move. Whether you're seeing something on the screen or not, I've given the options before you. Let us proceed. Yes. Before. Okay, let's do a quick switch right now. Let's do a quick. Yes, I'm listening.
You're saying
Yes, yes. No, this one is the previous. It's not
previous,
really,
you know, it's
not really recent.
right now we can look back because we left stop it.
No, it has not done. It has not
That
done.
was
It has not reached. Mm. All right. I want to move to physics right now. I want to move to physics right now. And we are looking at specific heat capacity. Specific heat capacity. And what is specific heat capacity? What is heat capacity? Are you presenting another link to them? Is there another link? All right. My take on them, which link are you switching to? This is the only link that is available. There's no other link. So it's network, right? So my take on them, are you seeing the screen? Are you seeing me? Are you viewing what we are doing now before I switch? Elijah, are you following us before I switch? Okay, Clement is telling me that it's okay now, but it's glitching. It's glitching a bit. Do well to comment so that I would know. All right. So let me begin physics. Whatever happens, just be letting me know. Is obviously the only part that we're going to look at. We're supposed to look at vibrations in strings and pipes, but I have made a YouTube video on vibration in strings and pipes, which I'm going to release it next week. So you have to be alert next week because I will treat specific capacity. I'll release a video for you next week so that we'll treat this a little bit of this and we move to a little bit of mathematics. All right. So I think you need to clear that number 7 chemistry question that's on the screen. Which of the following is saturated hydrocarbon? Okay, just clear this. All right. All right. So we're on physics now. We're on physics now. All right. So don't worry, whatever you're saying is going to clear. Just let your neighbor verify by itself. Specific capacity. The specific heat capacity of a substance is a quantity of heat required to raise the temperature of a unit mass of a substance by 1 degree Celsius or 1 Kelvin. I repeat myself. The specific heat capacity of a substance is a temperature, you can define it this way too. Specific capacity of a substance is a quantity of heat required to raise the temperature of 1 kg of a substance by a degree rise in hot. There is a difference between heat capacity and specific capacity. Another name for heat capacity is thermal capacity. You sure you cleared it? I'm still seeing question 1. Yes, on the screen. Okay, I've cleared it. All right. I think it's a playback. All right. So, Victor, I believe you're seeing me. So I'm taking the definition again. I take the definition again. That specific capacity of a substance is a quantity of heat required to raise the temperature of a unit mass of a substance by 1 degree Celsius or 1 Kelvin. Or you can define it this way, that specific capacity is a quantity of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius or Kelvin. Specific capacity is a quantity of heat required to raise the temperature of a unit mass of a substance by 1 degree Celsius or 1 Kelvin. Or specific capacity is the quantity of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius or Kelvin. There's a difference between heat capacity and specific capacity. Heat capacity is a quantity of heat required to raise the temperature of a body. Heat capacity is a quantity of heat required to raise the temperature of a whole body. But specific capacity is a quantity of heat required to raise the temperature of just a unit mass. All right.